Hello, in this demonstration, I will show how to summarize PySpark classification models. So here's a classic setup for a logistic regression. We've got a pipeline that starts with our formula, and it's going to take all of the columns except for the column we're going to predict, which is fraud or no fraud. We're going to use logistic regression to predict that fraud or no fraud. So once we have this pipeline, we're going to fit it to our training data. And once we have that training data fitted to this pipeline, we get a model. And that model, then we can print out some information on how well the model fit against the training data. And I'll show you how to do this. I've got a function that prints out this information. Prints out classic information you'd like to know for classification. The accuracy, false, positive rate, true, positive rate, F measure, precision, recall. And that's in the aggregate, but you can also take your labels. In this case, I've got two labels for binary classification. And so for the 0 label, you can print out its F measure, precision, and recall. And the same for the other label. And then later on, I'll show you if you have more than two, some multi-class classification, you can print out the measures for all of the classes involved. So in addition to that textual summary of metrics of the model fit, we can also have a graph. A ROC curve is common. And in this case, the upper left is where you want your model to be. It's a better model as opposed to lower right, which would not be good. And we can also plot recall versus precision. In this case, the upper right is where we want the model to be, and that would indicate a better model. So these two charts, as well as the confusion matrix, are fairly common when you're trying to understand how good a fit a model is at classifying things. This confusion matrix shows you actual classes, labeled classes, like the actual value should be 0, and we predicted 0 99.9% of the time. That's good. And in other cases, when the class should be 1 for fraud, we predicted fraud 65 or 63.5% of the time, which is, okay. On the other hand, the actual class was 0 sometimes, and we predicted 1 instead incorrectly 36% of the time. So this matrix will show you how well you predict the various classes. In addition to binary classification, you can have multi-class classification. So here I've got classes 0 through 6. And for example, when the actual class should have been 0, our model predicted 0 71% of the time. But unfortunately, it also predicted for 0, it predicted class 6 30% of the time. So that wasn't so good. So I'm going to show you all these charts and also the text summary and how to do it in PySpark, because these are common things you want to do when you do classification. So let's go to Databricks for a demo. Here we are in Databricks with a notebook for classifying credit card fraud data, binary classification. We'll first download the data, then we'll read it into a Spark data frame. We can display the data, and we're going to call this data frame credit card fraud. We'll have a pipeline here. We're not going to use these other columns, but all the other columns we'll use, and we'll predict class from the other columns. The class is either 0 or 1, 0 for no fraud and 1 for fraud. So once we have that formula, we'll use that in our R formula, which will be part of our pipeline, and that R formula will be used in the logistic regression. So once we have this pipeline, we're going to fit that pipeline to our training data. And once we have that training data, then we can use the model summary to print out metrics about how good a fit the model fits the training data. So what we'll do is we'll take the fitted model and take out of the two stages, we'll take the second stage, which is the logistic regression model. So we got LM for a logistic model. Once we have that model, then we can get information from it. We can get the summary and accuracy and other information. Here's the accuracy. So to simplify the printout of all of these metrics associated with the model summary, I've written a function here that's going to take the model summary, LM summary, and print out the F measure, precision, recall, and all the rest. So that's what this does. It takes the classification model summary and prints out the various metrics that are handy: accuracy, false positive rate, true positive rate, F measure, precision, recall, and so forth. Once we have that, that logistic regression model summary, we can also print out other things from the model summary, such as the ROC curve. So we can get the false positive rate and the true positive rate from the model summary by selecting these, and in this case, converting it to pandas so that we can plot it. We just have a line plot here. We're plotting the false positive rate against the true positive rate, and that's what the ROC curve is. The summary also has a summary of the area under the ROC curve, and that's printed here at the top. You might be interested in looking at the training data predictions, and you can do that by transforming the model over the training data, and you'll get a column here on the right with the predictions. And mostly there's 0 because there's no fraud, but eventually if you scroll down enough, you'd find some fraud marked as 1. All right, a little bit further, we can print out the precision and recall curve for binary classification. And again, this is found off of the logistic regression summary class. And there you have PR, precision recall, and you can select the precision recall values. In this case, convert them to pandas. And then once you have that, you can do a line plot. And that's all this is here. And so we also have the total area under the curve here for our training data. These predictions, by the way, were from the training data, and I use these predictions below to pass it off to the binary classification metrics, which then computed the area under the precision recall curve. So that gives us that chart. Okay, next up is a confusion matrix. And once again, once you have selected your actual value and your predicted value, you can then pass it off to multi-class metrics, and you can produce a confusion matrix. It's provided by this multi-class matrix. There's a confusion matrix, which is a dense matrix, but you can convert it to an array and then eventually convert it to a pandas data frame. And once you have that, you can use the Seaborn heat map to print out the percentages shown here. So I'm dividing the actual values by the total values and printing it out as a percentage. But I also show how here you can print out the actual numbers instead of the percentages. That works as well. All right, so we're done with that. Now what happens if we have some test data? So once we've created our model from the training data, can we then apply that trained model to some new data, some test data, and then get some fit of how well the trained model performs against the test data? All right, so that's what this is about. So there's a multi-class metrics that allows you to get a number of values out, and that's what this is all about. It looks quite similar to the values metrics that come from the summary of the logistic regression model, but these are not from the model. These are computed from the actual versus predicted values. Okay, so once you have that, then you can take these metrics and print out various things, and here's the summary of those things. So for for binary classification, you can also get the area under the precision recall curve and the ROC curve, and those are printed out here. But in addition to that, you can get the accuracy, F measures, and so forth of the model, how well it fits the test data. Okay, in addition, you can take the confusion matrix produced from the test data and print out the confusion matrix. Note, again, this is the trained model against the test data. So this confusion matrix is different than the trained model against the training data. So if you look at this upper right, you've got the actual value is 0, and the predicted value is 1 at 43.9. That's different than the actual value versus predicted value of the trained model against the training data. You can see that the errors were not quite as bad with the trained model, but when we apply that trained model to some new test data, we had a little bit more errors here. Okay, so now on to multiple class classification. In this case, it's a new data set where we're looking at some steel, and it turns out it has some faults in the steel, some problems with the steel. We read the data, and the faults are all found in multiple columns here, but using this method, we put all of the faults into one column. And there's a variety of faults. I think there's 7 faults. So in any case, once we've got that data, we're going to predict these 7 classes 0 through 6, and we're going to call that data false. And once we have that, then we're going to go ahead and do the same thing we did before. It's really identical. We have our formula that's going to take all of the columns involved and then predict that fault column. And we're going to use the training data with our pipeline. And as before, we're going to pull out the logistic model here, and we can print out a summary of it. Once we have that summary, then we can go ahead and use our function above to print out a classification summary that includes the accuracy, F measure, and then in this case, there's multiple labels 0 through 6, and we get the individual F measure precision recall for each one of those labels, how well it predicts each one of the labels. That's with our training data. We can also take that training data and predict on that training data. And using those predictions, we can produce a confusion matrix. And that's what we have here, confusion matrix with the training data. So this is a multi-class classification confusion matrix. Next up, we can take that model that was trained on the training data and apply it to some new data, some test data. And now we're not going to use a summary of the model, but instead use a classification metrics to determine how well it performed. So in order to do that, we're going to take these predictions from the test data, and we use the function above, which is classification metric summary. And here we get the summary that we had before, but this is with the test data. Okay, next up, it returns a confusion matrix, and we can also then print out the confusion matrix here. So this is trained on one data set and then tested on another data set. So once again, we can look at this upper left and see that the actual value of one of our classes was 0, and we predicted it at 63.9% in the test data. Whereas in the training data, we had that 0 class predicted 71.4% of the time. So it's common that the training data metrics are higher than when that same trained model is applied to some new data. All right, that's a summary of using PySpark to classify data and then show how to summarize the fit of those models against the data. I hope it works for you.